Good morning. My name is Asad Khan. I'm doing my MPhil in geology, and I'm just covering the part of petrology, that is the rock study, basically from Pakistan. Very interesting, but seems to be a very few geologists here. Yeah. Before starting my topic, we will discuss about our Earth. Basically, was the one of the supercontinent called Columbia back in 1.5 giga nm, that is around about 2200 million years ago. And then the plate actually changes, and the Columbia converted into Rodinia, and then the Rodinia actually converted into the Gondwana land on which we live nowadays, actually the Indian subcontinent, to which my the study area lies. So the Indian plate we will discuss that lies in the Gondwana. Yeah, I'm covering the part of Himalaya, and Himalaya is, all of you, that is a mountain range which is formed due to the collision of the Indian plate with the Eurasian plate. And a huge mountain range forms, which covers around about 2000 kilometers from Pakistan, India, Nepal, Bhutan, and then Tibet, China. And that's the way that Indian plate goes and then collided with Eurasian plate. And we have the collision of the Himalayan mountain system. That's the whole Himalayan chain, starting from western Pakistan to the southeast Tibet. And many authors, they divided the Himalaya into 3 to 4 categories. We have the greater Himalayan sequence, lesser Himalayan sequence, and tertiary symbolics. This is the map of Pakistan, to which my area lies. And Pakistan basically consists of 3 tectonic domains. That's the Asian plate, means the Eurasian plate, and the Indian plate. And in between them, there's a sandwich part, which is called Pacistan Island Arc. So when India collided with Eurasia, they got the sandwich part, which is called the Pacistan Island Arc. So the Pakistan consists of 3 tectonic domains. That's Eurasian plate, Pacistan Arc, and Indian plate. Yeah, because my rocks are granites, and the granites form as a result of the magmatism, that is the melting of the rocks, and they actually solidify beneath the earth crust or above the earth crust. The granites, they are crystallized below the earth crust, so we termed is as magmatism. Now magmatism in Pakistan and in Himalaya, there are 3 periods of magmatism, which actually starts from the Proterozoic magmatism, which span from 2400 to 1800 MA. Similarly, we have the Paleozoic magmatism, which starts from 570 to 240 MA. And then we have the tertiary or the recent magmatism, which is occurred due to response of the Himalayan orogeny, which occurs around about 50 to 45 MA, that is Eocene time. So our study rocks, they are consider all 3 of them possibilities. Some of the characteristics, they actually resemble with Proterozoic magmatism. Some of the characteristics, they actually resemble with Paleozoic magmatism, and some of them are the characteristic of the tertiary magmatism. That's why these rocks are very interested. And one point to be noted, that these rocks have never been sampled. They have never been studied geochemically. So I am the luckiest one that I have just picked up these rock samples for the first time, because the area lies in between the border of Pakistan and Afghanistan, which is actually the war region. So I am the first to be honored that I go there and just collected the samples. That's the star area, shows my location, which is basically the northwesternmost margin of the Indian plate. So that's the very complicated zone, got the interaction with Pacistan Island Arc, got interaction with the Eurasian plate, and got interaction with the central Afghan block as well. That's the rock sequences we have in the gorge. The gorge which I studied is called Nangarhar Gorge, by the name of the province in Afghanistan, which is called Nangarhar province, very famous province. So these are the rock sequence. We have the Murray Formation, and then Murray Formation, which are the Miocene, very recent sediments, and they are overthrusted above these all older sequence. We have limestone, quartzite, we have slates, dolomite, and then my rocks, spinel crystalline complex. Why they are called complex? Basically, they got a variety of rocks, so that's why they are called complex, not single term like granites. Or they got the amphibolites, which are the basic rocks. They got the sediments. They got the granites. So a lot of varieties. That's why in geology the term complex they call. So we divided the spinel crystalline complex into two units. One is the granitic gneiss and one is the leucogranites. That's the rocks under the thin section under the microscope, the granitic gneiss. You can see the brown biotite which align themselves. They got some orientation. And the other slide is pictures about the cross-slide having quartz, plagioclase, and feldspar, the mineral content of these rocks basically. This is the image of the ChemScan analysis. We have mineral assemblages under the ChemScan technology. We have the biotite, chlorite, the main minerals, and the quartz and plagioclase. And you can see that the plagioclase feldspar, the bluish color, that's very dominant in these rocks. So that's got a very indication for these rocks, their source characteristic, which we'll discuss further on. That's the rock area, which I just, that's the Nangarhar Gorge. And these are called the granitic gneiss of spinel crystalline complex. And you can see the red line. This is called amphibolite basic dikes, which actually intruded into these rocks. So sometimes they're in the form of dikes, sometimes they're in the form of sills. When they are perpendicular, they are called dikes. When they are parallel horizontal, they are called sills. These are the granitic gneisses. The other rock unit, which are called leucogranites or the tourmaline bearing granites. So these are basically tourmalines. You will well known about the tourmaline used in gemology, in gems. So these are the tourmalines under the microscope, and that's in cross lights, a very beautiful zone tourmaline grain you can see on your right side. Again, the ChemScan image of the tourmaline bearing granites. You can see this area, the above area is basically a tourmaline vein, which actually cross-cuts these rocks units. This is the field photograph for tourmaline leucogranites. And these fibrous growth of tourmaline, that's very rare in Himalayan geology. There have never been found such type of tourmalines in the rest of the Himalaya. So these are very unique tourmaline, and you will doing some mineral chemistry for that, hopefully. Then we have discussed about the geochemistry of these rocks, and we have plotted them. And you can see the red ones are the spinel granites. The red ones are Mansella and Utla granites. These are basically the Mansera and Utla. These are the Paleozoic granites, which we discussed in the first slide. While the Dober and Shang granites, the bluish one, these are the Proterozoic granites, which we discussed in the first slides. So you can see our rock units, they are plotted in the per aluminous, means they are per aluminous granites, means they got very rich alumina as compared to alkalis. Alkalis means sodium, potassium, and alumina means the aluminum dioxide. Secondly, we can see they are plotted in subalkaline. It means that they are very having low value for the alkalis as compared to alumina. That's the tectonic model, how these rocks form basically. So you can see that Indian crust actually subducted beneath the Eurasian plate. So we have the melting of this part of the lithosphere, as a result of which the magma formed, and it comes on the top of the crust. Similarly, we have the asthenosphere upwelling, which is the hot magma that rises above the earth crust. It actually accumulates here and then solidify this continental crust. And as a result, when it solidifies, it forms these granites, which are the leucogranites, the tourmaline bearing units. So we actually satisfy this diagram by our geochemical data as well. And you can see that's the reddish is our spinel crystalline complex that plotted within the syncoliginal and volcanic arc granites. It means that they are associated with the subduction of the Indian plate beneath the Eurasian plates. So that's the hypothesis we satisfy by our geochemical data as well. That's the silicon dioxide and yttrium we plotted against the major and trace elements. And again, we have the plotted in the volcanic arc granites. Similarly, these are the RAE which got that they got a very huge enrichment of the light REEs, rare earth elements. So there is another targeting for their REEs in Pakistan, such as China targeting these REEs nowadays. These are the source rock characteristic, which shows that these rocks got most of the Semitic source, means the sandstone or the gravakes or the older Indian basement rocks, they have been melted and they form these rocks. So again, the another manifestation of our geochemical data. Then comparison of the other geochemical, same rocks has been exposed in Namcha Barwa in Tibet. The same rocks have been exposed in Nanga Parbat. The C1 are called Indus syntaxes, Bisham granites, and D is our area. So that's the correlation of our data into other parts of the Indian plate. That's the geochronological dates, and the concluding remarks are that these rocks are formed as a result of the subduction of the Indian plate beneath the Eurasian plate. And we have the isotopic dates as well, which will be coming in hopefully next of weeks, which will shows the age of these rocks. And then we will assign these rocks and we will table them according to their age into a Paleozoic magmatism, Proterozoic magmatism, or tertiary magmatism, which will be a new edition of granitoids in the Himalayan geology. Thank you so much.